Okay, our fourth and final question is how can we guarantee continuity? So this could, theoretically be a multiple choice question maybe or something like that in terms of the AP test. And you'll see this a lot of times combined, in terms of the AP test, combined with the idea of differentiability, which we'll be discussing in Unit 2. So we're going to start off here. This is, I would call it a fairly basic version of this type. We'll call this example 1, just to help us model kind of the thought process behind what we're doing. But if we have this piecewise, f of x equals x squared plus a when x is greater than or equal to 3, and x squared plus x plus 2 when x is less than 3, if we want to solve for a in this case, to guarantee the continuity of the function, we would think about our 3 criteria. And the first criteria, remember, is that the point has to exist. Well, I've got a point. That point is 9 plus a. But knowing that the point is 9 plus a doesn't really help me solve for a. Okay, great, fine and dandy. The point's 9 plus a. Okay, it's actually the second criteria that I'm going to be using to help me solve for a. The second criteria is that the limit has to exist, which means I need to know the limit as x approaches 3 from the left and the limit as x approaches 3 from the right. Okay, 3 from the left is this bottom function, which is 3 squared or 9 plus 3 plus 2, which is 14. Oops, sorry, from the left. And 3 from the right is this top function, which is 9 plus a. Okay, well, the reason that this second criteria helps me solve the problem is because the second criteria says the limit has to exist, and for the limit to exist, 14 has to equal 9 plus a. If they do not equal, the limit doesn't exist because the two sides don't agree. And so then I can go ahead and set 14 equals 9 plus a, because they have to equal in order to guarantee continuity. That helps me figure out what a is. If I subtract the 9 over, I can see that a is 5. Okay, so our second example here, f of x equals, let's do 2x minus 3 when x is less than 4, and x squared plus b when x is greater than or equal to 4. Why don't you go ahead and give this one a shot and then restart the video when either you have an answer or you are stuck. Okay, so f of x equals this function. The limit as x approaches 4 in this case from the left of this function is this top, so 2 times 4, which is 8, minus 3, which is 5. And the limit as x approaches 4 from the right of this function is the bottom function, which is 4 squared or 16 plus b. And in order to guarantee the continuity, I'm going to do 5 equals 16 plus b. Subtracting the 16 over means that b has to equal negative 11. Okay. Like I mentioned at the beginning, this is, I would call it the more basic level of this type of problem. We do want to move into this slightly more complicated version here as far as where we are in Unit 1. So example 3 is going to be this piecewise function. F of x equals, we're going to do negative 4 when x is less than or equal to 1, ax plus b when x is between 1 and 5, and 4 when x is greater than or equal to 5. Okay, so it's not like these problems are, I would say, mind-blowing mathematically. These aren't crazy challenging. They're just a little bit longer than the ones we just finished, and they have some places where you might want to be aware of potential mistakes, but they aren't crazy challenging. The issue here, and the reason they're a little bit longer, is we have 2 breaks, right? We have one at 1 and one at 5, and so we're actually going to have 2 sets of one-sided limits that we will be setting equal to each other to create 2 different equations. Okay, first we are going to have the limit as x approaches 1 from the left and from the right. That'll be our first pair here. 1 from the left is this top function, which is -4. 1 from the right is this middle function, which is a times my x, which in this case my x is 1, so a plus b. And those two functions, or so I should say those two limits, have to be equal. Okay? My other set of limits is the 5 side, the limit as x approaches 5 from the left, and the limit as x approaches 5 from the right. Okay? Approaching 5 from the left is this middle function, a times my x, which in this case my x is 5, so it's going to be 5a plus b. And 5 from the right is this bottom function, which is 4. And those two functions are going to be equal. Okay, at which point, because I have two functions with two variables, I'm relying on my systems of equations techniques. You can use whichever one you are most comfortable with, so substitution or elimination or whatever the case may be. But every period so far has chosen substitution as their preferred method, although again that doesn't make elimination wrong, just makes it different. So if you prefer that, feel free to do elimination. I can support you in that increased strengthening of elimination. But I'm going to go ahead and model substitution because, like I said, that is what the other periods have picked. Okay, and all the periods chose to work with this equation. Most chose to solve for b, although I did have one that chose to solve for a. Okay, but if we solved for b here, we'd be subtracting a over to the other side to create -4 minus a equals b. At which point I can take this function and I can substitute it into my other equation, into that b. And I would have 5a plus not b, but -4 minus a equals 4. Okay, if you needed to distribute, you could. I don't need to in this case, so I'm just going to drop those parentheses. Combining like terms, I get 4a minus 4 equals 4. Adding the 4 to the other side, I get 4a equals 8, which means dividing that 4, I get a equals 2. Which means I can take that, substitute it back in over here, and I get -4 minus 2 equals b, which means b is -6. Okay. So one more. Again, my recommendation would be to pause the video, try it on your own, restart the video when you're ready to check your work or if you get stuck. One more here. We had f of x equals, let's do 3 when x is less than or equal to -1, ax plus b when x is between -1 and 5, and 4x plus 1 when x is greater than or equal to 5. Go ahead and give this one a shot. Okay, so my first pair of one-sided limits, limit as x approaches -1 from the left, and the limit as x approaches -1 from the right. So I approach -1 from the left, that's this top function, which is 3. So I approach -1 from the right, that's this middle function, which is a times my x, which in this case is -1, so that's -a plus b. So we have 3 equals -a plus b. Okay, second set, limit as x approaches 5 from the left, limit as x approaches 5 from the right. From the left for 5 is this middle function, a times my x, which is 5, so 5a plus b. From the right is this bottom function, which is 4 times my x, or 4 times my 5, which is 20 plus 1, so 21. And so 5a plus b equals 21. Now, depending on which method you choose, you chose as you were working through this problem, your work now might look a little different than mine. Regardless, you should still end up with the same answer. Okay, if you didn't end up with the same answer and you can't find where you made your mistake, put a little post-it note on it or something, and when you come into class, ask me to look at it and I can find, where your error was. Okay? But I'm going to go ahead and do substitution. I'm going to do substitution by adding this a over here to get 3 plus a equals b. So now I can substitute this equation in over here. 5a plus not b, but 3 plus a equals 21. Distributing if I needed to, I'd have 5a plus 3 plus a. I don't need to distribute in this case, so I can just drop the parentheses. 5a plus a is 6a. Subtracting the 3 over to the other side, I have 6a equals 18, and dividing that 6, I get 8a equals 3. Which means I can take that a equals 3, I can plug it back over here to get 3 plus 3 equals b, which means b is 6. Okay? And there you go.